Hi, buddy. This is Mr. Folly, and I apologize. This is the review slide, but I was laughing so hard that there's a Bachelor theme song, which you'll see why I found that so amusing before. Um, that will get there. So, hope you're getting all these notes. Just kidding. I'm getting back to the front. I hope. And you get to hear someone propose because it's so awesome. I hope you can hear this. This is Mr. Folly. And welcome to Podcast 10.4. Talk about how solutions form. That one's gone. Write dissolving equations, distinguish between solutions, colloids, suspensions, give it a mixture, describe techniques, can be used to separate it, which is what we did in lab today, in our virtual lab. Explain how to affect the rate of dissolving, define colligative properties. Wow, that's a lot of stuff. And I'm going to add dilutions on there too. So get your periodic table and calculator, and let's get going. Bachelor's so annoying. Solution formation is like the Bachelorette, but not as good looking. Solute-solute bonds must be broken. Solvent-solvent bonds must be broken. Okay, so what happens is if I have salt and I have water, salt is attracted to salt, water is attracted to water. Remember, they're polar, and these are actually ionic bonds. This is positive and negative. Okay, so those have to be broken, so endothermic, endothermic. And new solute-solvent bonds must form. So that means when this is all done, this negative has to then be surrounded by a bunch of water molecules. And remember, it's a whole bunch of them, because they're weak, but it's a whole bunch of them. So, for example, I don't know, who's a rock star these days? Will.I.am has a lovely wife. But when he's gone, there are a million groupies that want him to be unfaithful. Will.I.am might do that, but not Will.I.am. I like Will.I.am. So, new solute-solvent bonds form. That's exothermic. That's hot. Woo! Don't tell Will.I.am's wife. Molecular compounds. When molecular compounds dissolve, when you put sugar in water, it can dissolve. When sugar dissolves, it separates into molecules. How annoying that that is spinning on my slow computer. So what happens is, the sugar dissolves and separates into molecules. So what happens is I have a chunk of sugar, big pile, and then it turns into individual molecules. Okay? So notice the only difference is the state of matter. It turns into aqueous. Dissolving equations for molecular compounds are kind of easy dumb. All you do is write the same thing, CH3OH, aqueous. You drop it in water. If it dissolves, it's just aqueous. NH3 gas turns into NH3, aqueous. And how do we know if they're covalent again? They start with a nonmetal. I almost said the wrong thing. Start with a nonmetal, and really they share electrons. And remember, if they're going to dissolve in water, they're going to be polar covalent. Ionic compounds. Ionic compounds turn into ions when they dissolve, not molecules. So if NaCl dissolves in water, you don't get little NaCl's out there. You get Na positives and Cl negatives that are not connected anymore. They're surrounded by the little water groupies. Water groupies. Groupies. When water attacks. So look here. You got a positive ion, and it's pulled away here. So here's my positive ion. Hope you can see this. And it's surrounded by water groupies. Water groupies. So right now it's strongly bonded, but will the groupies pull away the water? Let's see. And notice these are, this would be like the CH3COH. Is that what it was? No, maybe just CH3OH from before. These are bigger molecules. I guess I should have looked to see what they are. But they're bigger molecules that stay together. Okay? And the water is still groupies with them, right? Just not as much. Because they're not as positive. Ionic compounds. Ionic dissolving equations show ions as products. Boink, boink. So, examples. If I have calcium chloride, notice I've got calcium here, and I have to go to the periodic table. When I go to the periodic table, 1, 2, 3, 4, 5, 6. Calcium's right here, so it's plus 2. Plus chloride. Chloride is right here, so it's minus 1. So now I have to balance these. Notice I have 2 chlorines over here. I put 2 of them over there. That balances the charge. Plus 2, 2 minus 1s make it minus 2. That would be 0. Magnesium nitrate. Now I don't break this all the way down. I hope you see that as nitrate as an entire unit. So I get magnesium. Magnesium's right here, plus 2. And then nitrate, NO3, and you go, oh, I remember my ions. I studied them, so. And I get NO3 minus 1. Notice I have 2 nitrates over here. I put a 2 here, and I move along. Colligative properties are dependent on the amount, not the identity, of the solute. There are only 2 colligative properties you need to know. So that's weird. The identity doesn't matter at all. So it doesn't matter what it is, just how much of them there is. Boiling point elevation. A solute will increase the boiling point. Doesn't matter what it is. Any solute will increase the boiling point of a pure solvent. Freezing point depression. Any solute will decrease the freezing point of a pure solvent. And that's rare to see. Boiling point elevation is a colligative property. When a solute is added to a liquid, the attractions increase. The increased attraction means it takes a more extreme temperature to boil. So if I've got water right here, and I've got a solute particle, the solute particle is like Mike Tyson. Everybody wants to hang out with Mike Tyson, so more of these particles stay here instead of turning into a gas and leaving. Admit it, you'd hang out with Mike Tyson if you could. Which has a higher boiling point, a 1 molar NaCl solution or distilled water solution? The higher boiling point would be the 1 molar NaCl solution because the solute is so attractive you'd want to stay there and hang out like it's Mike Tyson. Real world examples, hey, we've got a few. Making candy, the sugar and the water, so if I make rock candy, the sugar in the water increases the boiling point. So it requires a higher temperature to boil a solution. This means it can dissolve even more sugar. You can dissolve something like 300 grams. Oh, darn it, you died on me. Okay, this will be a 2-part podcast, so hopefully you'll watch part 2 as well.